Hi, welcome to Parametric House. In this tutorial, I want to show you 4 different tools. The first one, if you open the two curves folder, there is a cluster and an example file. Let me show you first with the cluster. So if I open this, okay, the first tool I want to explain is the two curve arcs. It's a really useful tool if you want to just convert two set of curves into a series of arcs and surfaces. So as you can see here, I've provided two curves for the inputs, curve 1 and curve 2, and there is also a number of division. So for example, if I just go here and draw a curve and also draw another curve, I can set this to the first curve and the second curve. Here you can see how easy it is. When I change this, it can simply give me a number of arcs. So if I want to use the arcs, I can bake this and use it in my project. These are the arcs I can use. And if I want the surfaces, I can bake and use these surfaces between the arcs, which I'm going to explain in the next tools. Also, if you, for example, give two circles to the input, you can see that we can produce these series of arcs and strips. There is an input called closed, so you can just hit true and false. As you can see here, this is really useful for closed curves, and you can use that. Let me explain also the example file. So if you open the example file, let me turn off everything and explain this step by step. So the first, and put the bifocals so you can see the inputs. Okay, we have simply two curves which we're going to use in the project. You have to divide these curves into a number, so that's really simple. You just have to give this number slider to the divisions. It's going to divide it into a series of points. Then what we have used here is in the curve and primitive, we have this arc SED, start, end, and direction. So the first point is a set of curve divided into points is going to go to the start. The second curve is going to go to the end. And for the direction, it's going to be used as a Z. So that is going to give something like this for the arc and produce the arcs like this. You can use other tools, maybe arc 3-point and other arc tools if you want to. But anyway, that's going to give you the arc. The next step is to connect them together with a series of strips. So I've used the Loft tool from the surface Loft. And for the option, you can use the Loft option tool. The most important thing is the type. So if you right click here, you can see that there is normal, loose, tight, straight, and uniform. For example, the default is normal, but you can use the straight. I'm going to extract that. So you can see that this is the number 3, and that's going to connect them into a series of straight surfaces. Also for the closed and open, you can use true and false. So if it's like a circular curve, so like the circles we had, you can use a true false to get the final results. And then if I just bake that, you can see that this is the surface. Because they are joined together, we deconstruct that and extract the faces, the surfaces. So that is also another output you can get. These are the curves and this is the surfaces. And if I bake that, you can see that the strips are separated from each other. Okay, the next tool is the polylines. So instead of curve, we can also use that as a polyline. For polyline, I have made two tools. One is for points and one is polyline. For the points, you can see that the inputs is simply a series of points 1 and points 2, which is going to define the polyline, and then a number of division, which is going to define, for example, the smallest part of the polyline. It's going to divide the other parts. So as you can see here, if I change the location, I can get different results. The logic behind this is also similar, but because it's a polyline, we have some extra tools to do. I'm going to explain that in the future video. Finally, we can get the arcs and the surfaces. Again, you can see that we have those strips as an output. There's also another cluster called cluster polyline, which you have to define a series of polyline. You can see this is like the first polyline and the second polyline. Remember that whatever polyline you are defining, The second one has to has the same number of edges, because if it doesn't, you're not going to get good results. I'm going to set this to the first polyline and this to the second polyline. And now you can see that we can increase or decrease the division. I'm going to explain the algorithm and what we have done to produce the results for the polyline. The next one is panel structure. So for example, let me show you with the cluster. If we have produced those panels, we have a tool here which we can, let me turn this off. Assume that we have given this strips as the input. We have used the first tool for that. There is an input for the flip. So if you have problem for the outputs, you can just flip the surface and it's going to give you outputs and results. So here there is a series of 0 and 1s. A 0 is going to define the panel output, and 1 is going to define the structural output. So you can see it here. And you can even increase the gene list to maybe 3. And for example, say I need 1 series of panels, then 2 structures, and again, it's going to repeat. So remember that you can even change that if you want to. So if you put it both to 1, the output is going to be something like this, which you can change the truss type, 0, 1, 2, like this. If you want to put it all to panels, you can put it to 0, and then you can change the number of count. Remember that we have defined the strips. Now we want to divide them into panels like this. And you can also put it like 0 to 1 to make it like that. As the output, we have the truss lines. We have the panels. If I bake that, you can see the panels here. And also we have the strips for the panels. Just a simple dispatching. You can do that also for the circular panels or strips. The next thing, I'm going to explain the algorithm as we go forward. Okay, the last tool is the inflated strips. So assume, I'm going to show you with the cluster. Okay, the last tool you can see here is the inflated strips. So you can give the surface strips to that. Remember that we can change the strips to 0, 1 if we want a series of structures. Anyway, when we have the strips, you can define how many division you need in the UV division. Then just change this inflation. Remember that small numbers can only work. So if I just put this to negative, it's going to inflate inwards. And if it's positive, it's going to inflate outwards. And finally, I can bake the meshes. So this tool is also really useful. I'm going to explain the algorithm and how it's going to produce the final results. Again, for the second example, you can just give the strips to the inputs, number of division, how much you want to inflate it. Remember that increasing this too much will break the meshes. So that's also an output you can get. And if I put it inwards, you can see that we can inflate them inwards. That's also useful if you want to make it like this. Okay, that's the 4 tools we are going to cover in this lesson. If you have any questions, ask below, and let's take a look at the 3 other components and tools. I'm going to explain them step by step as we have explained the 2 arcs.